Tonight is October the 27th, 2016. I'm going to make a video tonight on both audio amplifiers and amateur radio. This is an amplifier I built not too long ago, and I've posted a YouTube video on it where I can swap out these directly heated vintage 6B4s for the 6L6 KT66 type tube. Works great. Nice little amp. I'm going to use it as an experimental amp because I have a lot of these 6AS7s, 6AS7 or 6080, whichever one you want to call it. Looks like I've got two here that pretty well look alike. Same vintage. Can't see right off who they're made by. I've got to test them all. Here's three Sylvanias that look all physically nicely matched. Here's a couple say Hewlett Packard on them. Anyway, I got a bunch of them. I don't know how many of them are good. I got to find a couple of good ones. Hopefully some nice clean ones like these. And I'm going to rewire this to use them. Now, I know that a 6080 is used as a series regulator in power supplies generally. And here's its pinout right there. It'll take an entirely different wiring of the output tube socket, but that's okay. And I'm going to ignore what it's supposed to be used for, and I'm going to see how well it performs in an audio amplifier. I'll use cathode bias, the same as I did on this one. And I'll have to look back at my own video, but I think I was getting like 18 or 20 watts, or maybe 30 watts with this KT66s in here. I'm getting a nice amount of power with the James transformer. Anyway, that's one thing. You won't be seeing that video tonight, but that's what I'm going to do because I just got to know. I do videos like that using those kinds of tubes and making the measurements that I do because I don't see them anywhere else. And I don't want to just talk about it and have blogs about what will happen and what won't happen. I'd rather just build it and see what will happen. And secondly, I'm going to clean the contacts on this right here. And this power supply, and I'll show you some anomalies I have had to deal with, particularly in this power supply here. And I've had conversations on the air and on YouTube about some issues I've had with, in particular, this power supply and some arcing. These old radios, this is Collins a 32S1 single sideband exciter. Does about 80 watts output. It's called a winged emblem. It's the older model, probably made in the very early 60s. I'm going to guess around 62 or so. I've had it 35 years. It's a beautiful little instrument. Use it a lot. Here's what it looks like inside. All vacuum tube. I have replaced the capacitors in it for the ham radio operators that are interested in that. I lovingly hand select every tube in it. Try to keep it clean. Briefly, before I get into anything specific, here's the power supply. Might be a little dark in there, but I use the original rectifiers. I do not put solid state rectifiers in it. I think that's a really bad idea. But I've had some arcing problems in here that I want to show you, and what I did to help solve them. Because my ultimate intention here is to preserve this old equipment. Show how to clean the sockets. Show what happens when you have open pins on some amplifiers, particularly the audio amplifiers that I have experienced. So I'm going to clean off the workbench. I'm going to take this equipment off and the tubes, and then we'll just focus on this one for a few minutes. It'll only take a few minutes, and then I'll pull the cover off and show you the way that I clean, especially these band switches. These things get dirty, and you're always having to do that to them or wiggle them a little bit. That's not uncommon, but you know, you want to be very careful when you clean these things because you can replace every tube in it. That's no big deal. You can buy every tube in it for practically pennies. But if you do something terrible to this wafer switch, you've junked it. So anyway, let's get started. Okay, well, what I'm going to get started with here is, some of it is not new. Some of it you can see on many different videos of on YouTube, and some of it I think I have some unique experience into these whole amplifiers. So I'm going to start with that first. Well, I think everybody knows that you count the pin as if you're looking at it from the upside down. You count it in a clockwise position. So on the top it would be counterclockwise. This is pin 1, 2, nothing's on pin 1. Pin 2 is the filament, pin 3 is the plate, 4 is the screen, 5 is the control grid, nothing on 6, 7 is the filament, 8 is the cathode. Well, one of the things that can happen that can really cause you a lot of grief is there's two very, very important pins in here that if something goes wrong with the connection between this female pin and the male pin here, you're going to have some serious problems. One of them is pin 3 and the other one is pin 5. Let's start with pin 5. Pin 5 is the control grid. If you have a fixed bias amplifier, that is where you could adjust the bias. You know, the word adjustable bias and fixed bias kind of crazy there, but the other one is called cathode bias, where you have a resistor in the cathode lead right here at ground. But if you have a fixed bias supply that you can vary, and the connection between pin 5 and the tube goes bad, you lose the grid bias. So the plate turns screaming red hot. And oftentimes, well, I won't say oftentimes, but I have seen cases where when that happens, say the tube is running red hot, you can just get it and move the tube sideways just a little bit. Oh, and all the red will go away. Well, that's a pretty good indication it's pin 5. And then you move it the other way and the plate turns red again, move it the other way, stop. So you probably got a loose connection on pin 5, which could be dirty, or it could be that the female pin is wallowed out. On the new amplifiers, one of the reasons I quit working on amplifiers, and especially the new ones, is a lot of these sockets that are made nowadays that come from our dear friends in China are so very cheap, and the metal is so very soft, it has no spring tension to it, that when you pull the tube out by wallowing it around, what you end up doing is this little female pin here, you end up opening it up, and then it makes no contact anymore. Well, that's a problem you'll get with pin 5. Red plate. Maybe one of them's red and the other one's not. Well, an actual worse condition is for pin 3 to open, because virtually every amplifier, unless it's a high power SVT type amplifier where they actually run the 6550s as tetrodes, in all of these other amplifiers, the 6L6 family of amplifiers, we always run them as triode connected. Now, I know some people may argue with me and say, oh, well, you know, it's triode connected when the screen grid is connected directly to the plate, and it's not triode connected when it's running ultra linear. It's still triode connected because the screen is at the same potential as the plate. Maybe a few volts difference, 2 or 3 volts, which is insignificant. It's at the same potential as the plate. And here's what happens. If you lose contact on pin 3 with your tube, then all of the current flowing from the cathode to the plate ends up going to the screen on pin 4. And guess what happens? It smokes your tube in about 2 or 3 seconds. And you don't even know it happened, really. Except now your amplifier puts out half as much power as it used to, and at higher volume it sounds awful. So what do? So you go, dadgummit. So you order a new set of tubes and you put them in there, and somewhere between instantly and sometime in the future, this pin 3 gets loose again, smokes the screen. Same thing. So you could spend $1,000 on output tubes and you're going to smoke them all because your pin 3 opens up. And pin 3 in particular likes to open up on cheap sockets because it's the plate pin and it gets hot. the plate gets very hot, the heat runs down the little wire from the plate to the pin, and pin 3 is running hotter than all the rest of the pins. So it's likely to do more damage to the female pin there. I hope what I'm saying makes sense, because I know it's true. Well, if you do have a walled out pin, you can change the socket. You may be able to go in and reform the female pin slightly and make it tighter, assuming it's a good enough socket to do that with. You might need to replace the socket. Or in some of the old vintage sockets, even like these, you can actually pull the pin out and put a new pin in. I personally don't use new sockets. These sockets are probably about as old as me. Well, maybe not quite. I'll be 67 in a couple of weeks. I don't think they're that old, but they're probably 50 years old. They come out of military surplus stuff. That's the only kind of tube sockets I use, and I don't have that kind of problem with these sockets. Okay, now for cleaning. Cleaning is a good idea, and I'm going to clean this one, and especially I'm going to clean this amplifier, this little transmitter down here, and here's what I use to clean it. You'd think I own stock in this company, but I don't. But I like to use, I have a whole lot of this stuff. I don't know why I have so darn much of it. I use this little brush stuff. I can't do this. I'll have to put my camera on a tripod. And let's see, I like this one right here, where you can use little tiny drops. I use a little bit of this spray sometimes. You got to be careful, because this stuff is very oily. It works great. I love it, but you got to be careful. It's oily, and I'm going to put on some gloves too, because I've already got my fingers oily. Now let me show you what you don't want to use. Not in an amplifier that you care about. You don't want to use this kind of stuff. This stuff you can get like at Lowe's and Home Depot and all that. This is good for like cleaning the connectors that go from your truck to your dune buggy carrier. You know, those kinds of big connectors. Here's the same thing. This other contact cleaner. You can see I have a lot of it. Electronic cleaner. Same stuff. It even shows you cleaning larger contacts. That's just, everybody needs some compressed air to blow it out every once in a while. You need all kinds of cleaners. Carb cleaner, oh my God, I don't know why that's up there. Well, probably do. I've been working on a carburetor on my old Jeep lately. Acetone, be very, very careful with acetone. Denatured alcohol is pretty good. I like denatured alcohol. I have some other exotic cleaners up here, some that you might find rather odd. Well, let's see, there's more denatured alcohol. This is a form of trichloroethane that was surplus from white sands. Actually, I have some real trichloroethane. This is really good stuff, but it's pretty serious. You don't really want to mess with it too much. Believe it or not, chloroform is a very good cleaner. I'm not recommending you go out and buy any of this, but I'm telling you, if you run across it, you might like it. Okay, so back to the stuff for real electronic type cleaning. This is all I use, this type of stuff. It only takes a tiny amount of it. This stuff right here, you can just put the tiniest amount in there, and you don't want to scrub it. Not your contacts like in this little radio here, because like I said, if you mess up the wafer switch in there, you've bought the farm. Okay, let me put this thing on a tripod and I'll show you how I do it. Pretty much like everybody else on YouTube does. Okay, now as long as I can keep everything in the middle here, what I do is I use this stuff with the brush. There's a couple of different kinds of it here. 2 different kinds. Take your choice. Just tiny amounts of it. And I go through and paint the tube pins. Very little. You know, one little dipping and you could do the whole socket. The whole tube. And then you can do the same thing, being very careful not to spill it. You don't want to make a big mess. You can wiggle it down in there, depending on, you know, just how corroded you think it is. You don't want to get too weird with it. I'm showing you something that's just intuitive. Let's see, the spray stuff. Well, It's actually okay if you want to, if you need to spray it in something, but I prefer not to spray it because it's pretty oily. And they also come with some of these little cleaner things. I use sometimes, depending on how dirty it really is, so that you can go down in there and, you know, clean it out. So there you go. It's pretty intuitive. You know, I think there's YouTube videos out there on how to use all this stuff. But works good, lasts a long time, in my opinion. Put that back together in a minute, and then, of course, you plug your tube back in. That's about it. Like I said, besides having mechanical female pin problems, that seems to be all I need to do. I do the same thing for the pots. Well, these are sealed pots. These are those Allen Bradley pots. You don't have to clean those. They can't get dirty. They're all sealed up. They can get scratchy though. But if you've got a pot that's open, you know, so that you can get in, put one little drop in it. Just one little drop from something like this. Not even maybe a whole drop. Being very careful, being very sparing with it. A little bottle of that stuff will last you for years. Now this is, I wish I'd have brought some sockets down to show you. But in my high power transmitter, the one I have in the basement, I run solid state 866s in there. And something I found out that you might find interesting is when you power up a power supply that has an output like that one does of 3600 volts, the 866 or the solid state version of the 866 has 4 pins on it. 2 pins were for the filament. The other 2 pins were not used, and it had a plate cap. Well, if the contact between the male pin on those 866s or solid state substitutes and that female pin is just the slightest bit loose, if there's not an extremely good contact between them, that high voltage is just really unforgiving, and it will arc and make a big kapow, and it's really pretty disturbing. So even if you might think that, you know, what could possibly a tenth of an ohm matter to 3500 volts? Well, I'll tell you, it matters a lot. It really pisses off the 3500 volts. So I highly recommend you keep those clean. I've had to clean those more than once. Well, that's really about all I can see and say for the audio amp. Give me about a week and I'll show you how the 6AS7's 6080s perform in this. Now let's go on to the little Collins rig, and I'll show you what I do there, which seems to fix it every time. Okay, now that we've got this little jewel out of its case, here's the front of it. I think it's pretty common that the switch that we have, those ham radio operators that have this old Collins S-line equipment, is probably this switch right here. Same kind of goes for the receiver, and it's pretty touchy. I don't know if I can show you very well down in there, but I'm going to try to lift my camera off the tripod here. You can see down in there. We want to clean those contacts, and then the rest of it is down in those holes. Let me get a flashlight and see if that helps. So, yeah, you can actually see the contacts in there. You want to be super careful. I'm telling you that, and I've got to live by my words here. Oh, some people have asked me about using Q-tips. I do not use Q-tips on my equipment, although I have lots of Q-tips. I live by Q-tips, but I would not try to put this thing down in that hole and scrub it, because you could bend it. And let's see, I don't think I can show you exactly, but you know, it's got little fingers. Yeah, you can see the little fingers in there if it focuses, and how they wipe with the contacts going through them. If you bend those things up or break them off, man, you are screwed. I don't know any nicer way to put it. So for that, I'm not going to be able to do it while holding the camera literally, but I take this kind of stuff with that long spout and I put it down in there, making sure that I'm getting just the tiniest of a drop about to come out. So I'm squeezing it. Yeah, right there, see? That is plenty. Don't overdo it. And you don't have to put it on every contact, but you just got to use your own good common sense and skill. And I'll do this one. All of these up and down here. There's a little pot right there for the S-meter cowl. There's some contacts right there. It wouldn't hurt to pull it out and put a tiny bit on there, maybe with a brush. I hope that you know, we can make these things last darn near forever. As you can see, these all have, I have replaced all of the paper capacitors in it. This one actually went bad several years ago, and I actually had to change that one to fix it. I changed these just kind of because it seemed like a good idea, and of course the electrolytics. There's another electrolytic in here somewhere, a canned one. Well, I can't see the darn thing upside down. I can't figure it out. Can't figure out where my brain is. Anyhow, I might even do a little bit on the the relay. Oh, by the way, relay. Oh, that's a good one. Looky here. Here are relay cleaning contacts. I will touch it up, but you want to be extremely careful with these relay cleaning contacts. Having to work with one hand here. Oh no, that's not the one. That one's been modified. Let me get one that hasn't been messed up. If I can find like a new one here. They come in these little packs. We used to use this on the old stuff out at White Sands to clean relays. Yeah, this stuff right here, you know what 400 grit sandpaper is? Well, this must be like 1,000 grit. I mean, it's just practically slick. The way that I clean contacts with that, and I always have, except I used to have to use that spray stuff, because I put a little bit of contact cleaner on it, and then get in there and just you just barely burnish the contact. You don't get excited. You don't want to, like, you know, scrub the contacts down to where they don't meet anymore. Just with the tiniest bit of contact cleaner, get in there and burnish it up, and be happy with it, and back off before you break something. That's all I can think of right now. Oh yeah, see, there's another one up there that needs tiny bits of cleaner on it, and then operate it gently around, and it should work and last a long time. I have to clean this thing every, oh, I don't know, every 3 or 4 years, and then it works. Okay, let me put this back. Let me finish this up, put it back good. Then I'm going to show you some interesting things on this little power supply down here that I had to deal with. Okay, well, one last shot of this. I think I've got it. I do remember that my plate grid ALC switch was a little flaky sometimes. I'd have to, you know, do that to get it to work. So I did give it a shot, a spray shot of some of this stuff. This stuff is metered, meaning that it just gives you one little, you know, each time you press it, so you don't blow it away. And again, you do not want to use that hideous. You do not want to use that hideous stuff like you clean auto parts with. For one thing, it melts plastic. Actually, this stuff right here is pretty darn hard. I don't think you can melt this stuff. But I have done some very, very regrettable things with even some of this higher end stuff. Even some of this stuff right here. This is really bad on plastic. It says it's not. It says safe on switch housings and most plastics. Well, most plastics are not all plastics. Oh, here's another thing I use. Fingernail polish. I have a bunch of different colors here for marking things. Not only marking them, but if I don't want to lock it down with this red Loctite, I lock it down with a little bit of fingernail polish, or sometimes, you know, note polarities. And here's another type of electrical contact grease that's good, like for putting on bulbs, especially like in your car. This kind of stuff keeps it, you know, the water off, keeps it from corroding. I guess this is my contact cleaner video of the night, huh? So there's that. A little bit of solder flux sometimes. Well, that's not cleaner. Well, in a way it is. Okay, well that's that. So I'm going to put this back together, and then I want to show you something that I've learned in the power supply for this guy that might help the ham radio operator with the old Collins S line. Okay, here's the power supply for the 32S1, and I think also the KWM2. I'm not sure. I think it's for some other transmitters, but here's a problem I've had with it before. I've had arcing. Let's see here. See, here's pin 1, 2. 2 and 8 are the filaments. 3, 4, and 6. 4 and 6 is where the high voltage goes in. So I'm doing this right here. So you can see it. 4 and 6 is where the high voltage goes in, and 2 and 8 is the cathode where the DC comes out. Now, I think you can see, well I can, you probably can't, it's kind of, it has arced from here to the chassis because it's got a little notch burnt out there. I don't know if these arced or not. I don't think they did. Maybe it was just arcing right there, the high voltage, but it's so close that it's just simply arcing from the side of the pin over to the chassis, and of course that, I guess, instantly blows the fuse. And I have not been running it at any higher voltage than anything else. So I put this Gliptol, this high voltage stuff like you used in old TV set high voltage, and then I put some on the bottom of the tube like that, and I haven't had any more trouble with it. I don't think this is a really common problem. Maybe I need to clean the sockets. Maybe that's what's wrong with it. Heck, I don't know. You know, maybe I got bad connections here. I'm going to clean the heck out of them right now. Go through the whole process. You can see I never had the problem over here with the 5U4, the low voltage side. But the high voltage side, there's as much as 800 volts DC. And it's just a standard center tap. This is a genuine old 5R4. Let me show you underneath it. I have replaced all of the capacitors and stuff in it. Oh, I did have another problem with it one time. See, these are new capacitors. These things are above ground, so I remember, I wrapped them with extra layers of tapes and then put some cardboard around it because this is above ground, this case, because these 3 capacitors are in series. See, here's the negative one right here. This is the bottom one, and then it's in series with this one. This one's in series with it. The high voltage is right there. So I insulated this one quite well. Put the same thing over here, extra tape and some little cardboard. Didn't take a lot, but just wanted to make sure that this piece of metal didn't pinch through that thin insulation right there and short the case to ground, because that'd be the end of my capacitors. But see, there's no arcing underneath. All this looks good. Just arced on the top of the socket. So if you have these strange intermittent fuse blowings on your old Collins S-line stuff, pull the 5R4 out and look. You may end up with the same problem I had. Another problem I had in this thing, not terribly long ago, looks like I didn't do the best job in the world here, but the high voltage wire right here from the power transformer arced to one of the other ones, and I think I know why. I think about 30 years ago, see how I had to insulate these guys? I think about 30 something years ago when I first got this, I did something stupid, and I believe I shorted the 6-volt line coming out of here. You know, it goes up to the transmitter. I believe I shorted the 6-volt line and got some smoke, and I probably damaged some of the insulation on these wires, and even though it took it more than 30 years to arc through, it finally arced. Don't know if these are the filament wires or not, but I think they might be. But anyway, I thought, oh no, my power transformer is bad. I mean, this thing was vaporizing fuses. until I got in here and started examining it and trying to find out, you know, what was shorted. Was it shorted to the case? Was the secondary winding shorted? Was the primary winding shorted? And anyway, this is what I found. That's what it was. I think I'll put a little bit more tape on it. I think I'll dress that up a little bit more too. But those are some problems I've had with this. This is probably something like that I caused, like I say, decades ago. But I did not cause this by trying to run, you know, more line voltage, or I didn't do anything to deserve this. It just looks like it's a little bit too close. So in case you have it, then maybe this will help you resolve your problems too. Let's clean these things. I'll show you what I'm going to do to this and see if it helps, and then we'll close this out. Okay, for this guy I actually am going to use these little brushes. I always keep a cover on this thing. This is off of a Q-tip, but I always, if I lose the caps, I always want to cover them because I don't want to stab that thing in my hand. That would be not pleasant. But I think I'm going to just those four, kind of generously dabble them up, and gave them a good one there. I never have used this before, but I think I'm gonna. No, it seems to be a good idea. I don't know if it was a loose connection or not, but I think there's every reason to say it could be, right? Cleaning them. Now we'll use a Q-tip to wipe that off with. Like I say, I love Q-tips, but we'll leave a little bit of that in there. And then I'll paint up the active pins of this thing, which are the red ones. Not getting too weird about it. Put the cap back on. Don't want to spill this stuff. Make a big mess. Looks like they got it back in. I guess I should do the same thing for the 5U4. But anyway, you know what I'm doing. But I did in particular want to show you those the things on the audio amplifier over here. That if you've got loose pins, like on pins 3 and 5, how you can smoke your tubes. Put new ones in there, smoke them. Put another head in there, smoke them. Then all of a sudden come to the conclusion that all of these tungsol or JJ or whatever thunderation tube you're buying is all junk, and they're not junk. You just got a mechanical problem in there. So let me show you one last thing before I close this out. Here's my beautiful 3400Z. I just love this little amp. This thing will deliver 750 watts to the antenna. This thing is powerful. It's just got the filament on right now. But if you like tubes, you can't help but love these little guys. 3600 volts on the plate. Well, let's see. I'll show you right here. Let's see, let's put it in the lock. There's its output. 750 watts. Under load, just a little over 3,000. With no drive. Well, let's see. No drive, it's a little higher. This WA4 QGA testing on frequency. Just to make it legal, right? That thing is just beautiful. Look at there. Can't get enough of these vacuum tubes. Thanks for watching.